Hi, welcome to our senior project final presentation. I'm Sophia.
And I'm Olivia. Our project focuses on developing a unified Python-based graphical user interface to streamline the measurement of lenition, a linguistic phenomenon involving the weakening of a consonant production. We call our tool LIPS, or Lenition Integrated Python System. Traditionally, in linguistic research, various lenition algorithms, like harmonic-to-noise ratio, are applied separately to audio data using various Pratt and R scripts, resulting in a tedious, inefficient, and irreproducible process.
Our solution integrates these algorithms seamlessly within a single GUI, eliminating the need for researchers to have technical command line expertise. Our goal of having a user-friendly interface empowers researchers to effortlessly run multiple algorithms, offering a more efficient alternative to the current approach. Unlike existing linguistic tools that are more general purpose, our specialized tool focuses specifically on applying Lenition algorithms to audio data, addressing a current gap in the field. Overall, our unified tool significantly enhances the speed and efficiency of data analysis, enabling researchers to make more impactful contributions to studies involving Lenition in speech. Now we'll go through a project demo.
All right, so this is the home page of our program. From here, there are three different pages we can navigate to. We could first hit the Load Files button to load in the audio and text grid files that we need to run the algorithms. After the user loads their audio and text grid files, they will be able to see the list of uploaded files on the right side of the home screen in that little box. If they made a mistake and wish to start over with the file uploading process, they can hit this Clear Files button and upload their files again by navigating back to the Load Files page. After the user is content with the files that are uploaded, they can navigate to either of the algorithms pages and run the algorithms using the uploaded files in addition to the parameters specified on each algorithm page. If the user has not uploaded files, clicking one of the algorithms buttons will show an error directing them to upload files first.
Now, when I click on the Load Files button, it brings me to the Load Files window. In this window, you see a space to upload audio files and the corresponding text grids. In the audio space, I can click Upload Files, and a file dialog box opens filtering only by the WAV files shown here. If I navigate to a directory with my data, I have the option to select one or multiple WAV files to upload. When I upload them, they show up listed in this area here. I can also remove them by selecting one or multiple and then clicking the Remove Selected button. I can do a similar process for the text grids by clicking some that I want to upload, and I can also remove. When I click the OK button, error handling is performed to ensure the corresponding audios and text grids in name and number are uploaded. For example, here, one of the audios does not have a corresponding text grid uploaded, so a message is displayed in red alerting the user to upload the corresponding text grid. It will do the same for the text grids, where in this case, this text grid file does not have the corresponding audio file. Now, if I upload all of the correct audio files and their corresponding text grids and click the OK button, it will bring the user back to the home page where the data is listed in this space here. And again, there's a Clear Files button giving the user the option to start over and re-upload any files.
Alrighty, so now that we have our files uploaded, we can run either of the algorithms. So I'm going to click on the Kingston/H&R algorithm button to navigate to the H&R/Kingston's page. So first, the user must input all of the parameters necessary for the algorithm to run, which includes the F0 minimum, time offset, smooth proportion, output file name, segment file, left range, right range, and low pass filter for the frequency band, and the lexical and labeled tiers. So as an example, I'm going to enter 100 for the F0 minimum, 0.05 for the time offset, 0.1 for the smooth proportion, test for the output file name, 0 for the left range, 400 for the right range, and 50 for the low pass filter. Error checking is done to ensure that each value is the correct type and within the correct range. It also checks to make sure that no inputs are blank and that every field has been entered. Since I forgot to upload a segment file, for example, I will see a pop-up letting me know that I have to upload a segment file when I hit the Run Algorithm button, as shown here. So I'm going to upload a segment file so that this pop-up goes away. Now, I am going to delete one of the input fields, for example, left range. If I try to hit the Run Algorithm button again, you can see that a message pop-up shows up telling us that the input is invalid and it specifies what the correct range and type is. So this same pop-up will appear if instead of not typing anything, I type a value outside of the range of 0 to 8,000. So I'm going to enter 0 again, which should hopefully get rid of this pop-up. Finally, there is error checking to ensure that the lexical and labeled tiers are not set to the same value, since they must be different for the algorithm to run properly. So if I set the labeled tier to 1, for example, and both combo boxes are equal to 1, and I hit the Run Algorithm button, I get another pop-up letting me know that the lexical and labeled tiers cannot have the same value. So now I'm going to set the labeled tier back to 2, and all of the error pop-ups should be gone. So before I run the algorithm, I'm going to choose to save these parameters for later use by clicking the Save Parameters button. This text shows up telling me that parameters are saved to a text file in this location. Now, if I exit this page through the Cancel button, I can go back into the H&R/Kingston's algorithm and upload these parameters into the boxes again, hitting the Load Parameters button. It opens this File Explorer, which allows me to select my desired parameter file, which I'm going to pick this one, and it fills in all of the values. So now I'm going to run the algorithm with these parameters. And this little pop-up shows up telling us that it'll take a few minutes, and since we only used a few files, the algorithm is done running, and it's telling us that the output is saved to the output/folder. So if I look into the output folder, which should be under UI, I will see that this is our output. It has the word test, which is what we specified for our output file name, followed by a timestamp indicating when the file was created. And if we open it, we get a file with the results. Oh, here it is. Okay, there we go. That was the segment file. So this is the file showing the results of the algorithm running for our H&R/Kingston algorithm.
Okay, and clicking on the Run Inferencing with Fonted Model button brings the user to the inference algorithm page. First, they must upload a pre-trained Fonted model, and this is a directory that consists of 2 other directories, which is the MT and the phonemes directory, as you see here in this example. First, error checking is performed to ensure the uploaded directory is of the right format and contains the appropriate files needed for the calculation. For example, here I uploaded a directory that does not contain an MT directory, so the user is alerted of that in red, shown here. Now, if I upload a directory that does not contain a certain model file, for instance, the user will be alerted of that as well, and shown in which directory they need to upload the correct files. Once I upload a valid model, the path is shown here. Then the user must upload a phonological feature chart that contains a valid dictionary. Here, error checking is performed to ensure the Python file contains a valid dictionary. As shown here, the user is alerted if that is not the case. Now, when I upload a correct phonological feature chart, the path is shown here, and the phonological features that are contained in this file are populated in this area here. The user can now select which specific phonological features from that file that they want to run the inferencing algorithm on, and they can select one or multiple. Once everything is properly filled out, the Run Algorithm button is enabled for the user to run the algorithm. Before choosing the Run Algorithm button, though, I can choose the Save Parameters so I can load these parameters back in later for future runs. Text is displayed telling me where the parameters are saved to a text file in this location. Now, if I exit this page and I click back on the Run Inferencing button, I can load in these parameters by clicking the Load Parameters button and navigating to the file location, which is right here. And you can see that there are parameters that were saved or auto-populated back in. Now I'll click the Run Algorithm button. A message is displayed for the user saying that the algorithm is running. This algorithm takes a couple minutes. And when it's done, a dialog box shows up here saying where the output is saved to. So if I navigate to my output folder, you could see here, this is the output of the inferencing algorithm, and I'll open the file so we can see the results. And here they are, a tab delimited file with all the information. All right, in terms of individual responsibilities for our project, Olivia and I worked on most of this project together synchronously. But my responsibilities include working with Olivia on integrating the Kingston/H&R and the inferencing algorithm into the GUI. I also wrote the code for the load and save parameters option for the inferencing algorithm and did the error checking and input validation for this algorithm as well. I worked with Olivia throughout the project on implementing any other additional GUI features present. Lastly, I contributed to the project documentation and GitHub README and performed unit and functional testing throughout the project.
I supported Sophia in integrating the Pratt algorithm into Python code and worked on modifying the Python inferencing algorithm to fit the specific needs of our program. I also wrote the code for the load and save parameters option for the H&R/Kingston's algorithm, as well as did the input validation and error checking for the H&R/Kingston's algorithm. Lastly, I contributed to the project documentation and performed unit and functional testing throughout the project. And thank you for listening to our presentation.